Since the dawn of consciousness, philosophers, poets, musicians, explorers, and scientists have been inspired by the heavens. This laboratory of the open night sky could be studied by anyone yearning to understand its secrets and significance to our daily lives. The birth of Islam in the 7th century, however, invited an even closer investigation of this celestial shroud, producing extraordinary spiritual, practical, and intellectual benefit for mankind. For Islam, astronomers determined the time for prayers and the direction of Mecca from any place on earth. They produced a lunar calendar and determined the dates of Ramadan and Hajj. For society, astronomers determined the length of a year, the seasonal landmarks for the successful cultivation of crops, and they created accurate tools for navigation over land and sea. The progressive power released by astronomy meant that it enjoyed generous patronage and conferred status to anyone associated with it. With this support and breakthroughs in related sciences like trigonometry, astronomy blossomed into one of the most prestigious and practical sciences of this time. This great success story began as medieval Western civilizations sank into the Dark Ages and a period of scientific and cultural degeneration. Valuable manuscripts and ancient wisdom were disappearing fast, neglected, destroyed, or simply forgotten. With the birth of Islam, the true value of this ancient knowledge was recognized. Gathering and consolidating this ancient knowledge was the first step along the road of Islamic astronomical discovery. Visionary patrons like the 9th century Caliph al-Ma'mun sent their men to gather these treasures from the far reaches of the world and bring them to the House of Wisdom in Baghdad. Here, the manuscripts were translated into Arabic, studied, corrected, and substantially expanded upon by Islamic polymaths and specialist scholars. So dynamic was the intellectual effort of the time that even before the ink was dry, new discoveries were being made, new techniques developed, and new instruments invented. Among the first manuscripts to be translated were Eratosthenes' calculations of the circumference of the Earth, and Ptolemy's great work known as the Almagest to Arabic scholars. In this book, which formed the basis for cosmology for the next 500 years, Ptolemy described the movements and pathways of a geocentric universe. As Arabic was commonly spoken and written by most Muslims, sharing this newly found knowledge knew no boundaries. Islamic scholars soon distinguished themselves through their empirical, practical, and integrated approach to research. This led to a new era of achievement, in which the blossoming of many related sciences such as geometry, trigonometry, navigation, cartography, instrument making, and even agriculture would redefine astronomy and set it on a new path of progress and innovation. The Caliph al-Ma'mun was astronomy's first great patron and a key architect of this new era. He was the first person to create and build a formal observatory with a library, study, accommodation, and instrumentation workshop. His idea of a large fixed working observatory with dedicated scholars that worked with focus to produce detailed astronomical tables, accurate star charts, calculations of the position of the planets, lunar phases and eclipses, accurate estimates of the diameter, circumference, and inclination of the Earth, as well as information for calendars, was truly novel for the time. He built the first observatory in Baghdad, and a second soon followed in Damascus. Other sophisticated Islamic observatories followed later, like the Maraha Observatory, founded by Hulagu Khan in the 13th century in Iran, the Ulugh Beg Observatory in the 15th century in Samarkand, the Malik Shah Observatory of Isfahan, the Tabriz Observatory of Ghazan Khan, and the short-lived Istanbul Observatory, established in the 16th century by Taqi al-Din. A strong focus at the observatories was the development of better and more accurate instruments for astronomy, geodesy, and navigation. These instruments included the sextant and quadrant, used to measure the altitude and movement of celestial objects, the universal and Fakhri and spherical astrolabes, 2- and 3-dimensional models of the heavens that help determine the time of day and the position of Mecca from any place on earth, the navigational compass, the celestial and terrestrial globes, and the armillary sphere, a series of concentric rings that showed how the universe worked. Islamic scholars were the real pioneers of huge observational instruments that dramatically reduced the margin for error. The observatory at Damascus had a 6.1-meter quadrant and a 17-meter sextant. The Maraha Observatory also had many large instruments including quadrants, armillary spheres, and astrolabes. So who were some of the great Islamic minds of this golden age that unlocked heaven's secrets and plotted the celestial paths of moons, comets, planets, and stars? Al-Battani, born in Haran, Turkey, worked in Baghdad. As an astronomer and mathematician, he compiled the Sabian tables, which would influence astronomy for centuries. He predicted new moons and eclipses, calculated the length of the year, and explained the phenomenon of parallax. He also recognized that our solar system moves through space and, as a result, made significant amendments to Ptolemy's observations. Al-Farghani worked in Farghana, Transoxiana, as an astronomer and surgeon. He was the first to explain the mathematical basis of the functioning of the astrolabe and corrected errors in earlier astrolabes. He calculated the distances of planets, the moon, and stars from the Earth. Abdurrahman al-Sufi worked in Isfahan, Iran. In 964, he described the first galaxy known outside our own, the Andromeda Galaxy. He wrote extensively on the astrolabe and star positions, their sizes and colors. Ibn Yunus worked in Fustat, Cairo, Egypt, and compiled the Hikmat tablets. Using a large astrolabe nearly 1.4 meters in diameter, he recorded over 10,000 entries for the sun's position over a 30-year period. Born in Iran, a hotspot for early astronomers, Al-Biruni was a classic polymath with expertise in mathematics, astronomy, geography, pharmacology, physics, and geosciences. Amongst his many discoveries, he observed that the Earth revolves around its own axis, calculated the Earth's circumference, and accurately determined the direction of Mecca from any point on the globe. Al-Zarqali worked in Toledo, Spain, and compiled the famous Toledan tables. He developed a sophisticated astrolabe called the Safiha that could be used at any location. Jabir ibn Aflah worked in Seville, Spain, as an astronomer and mathematician. He was highly skilled in spherical trigonometry and designed a portable celestial sphere, today known as a torquitum, for measuring celestial coordinates. Ibn Rushd worked as a philosopher, physician, judge and astronomer in Córdoba, Spain. Not only was he one of the most famous Muslim medical doctors, but he also discovered sunspots. Ibn al-Shatir al-Muwaqit worked in Damascus, Syria, as a timekeeper and astronomer at the Umayyad Mosque. He made many corrections to Ptolemy's calculations on the movement of the moon. These astronomers were some of the greatest minds of the time, and their models, treatises, catalogues and inventions laid the foundations for the giants of the European Renaissance. Nicholas Copernicus frequently referred to the works of al-Battani and al-Zarkali in his famous book De Revolutionibus. Tycho Brahe rediscovered the third equality of the moon's motion 600 years after al-Bustani had documented the same observation. Johannes Kepler utilized the works of many Islamic astronomers in the development of his laws of planetary motion. And Galileo Galilei and Isaac Newton's proposals of an early theory of gravity followed on from the work of al-Biruni and later al-Haytham. Today, the rich legacy of these Islamic greats lives on in the 13 features of the moon, named after Arabic astronomers, in the 165 stars with Arabic names, and in the many astronomical terms like zenith, azimuth, apogee and qibla, all derived from Arabic words. As we reach deeper into the mysteries of the universe, we owe much to these early pioneers of astronomy, who, in their fearless quest for knowledge, laid the foundations for modern-day astronomy and space science.